G'day team, welcome back, it's Matt. I've been traveling a lot for work recently. I've taken the time to plan and start buying everything for my next project. It's going to be a pretty big one and I'm pretty excited about it, and we'll get to it in a minute. But first, I'm going to wrap up something from the last video. The Masso encoder I installed is 12 to 24 volt input tolerant and provides a 10 volt signal. The Pokeys 57 CNC needs a 3.3 volt signal but is 5 volt tolerant. Mixing those numbers together are a recipe for letting the magic smoke escape. I've done it before, I don't want to do it on this. I've been using an optical isolator board I grabbed from eBay to convert the voltages, but it's quite bulky and it only has some of the wiring I need coming to it. It also doesn't natively interface the Pokeys IDE connector, so to fix this, I've knocked up a custom board using an online board supplier. They don't sponsor me or anything, but JLC PCB have been my go-to for this recently. The boards are nice and they work well. The Associated Parts store seems to have almost everything I need in it, and the Easy EDA design package was easy enough for me to work out how to use. My problem is the shipping kills me. When I buy other things from the Chinese companies, they offer an e-packet as a 13 to 20 day shipping turnaround for $2 to $5. Instead, with these guys, I'm stuck spending 20 Aussie dollar dues to ship $5 worth of boards or components. Does anyone know of any other company that works well for making boards with a better shipping rate? I don't need 3-day international shipping. Inside a month will be fine. Alright, back to it. The new board looks pretty good. However, I designed it wrong and the IDE pins or the IDE connectors are the wrong size. So, this is going to have to pause, and I'll come back to this one again later on. Hopefully I'll get it working one day. On to the new project. I'm going to build a mill. Yep, a mill. And it's going to be substantial. My design has it around about 1.2 tons. It's got a working area of 1200 by 800 by 400 millimeters, 4.5 kilowatt ATC spindle, so decent sized rails and ball screws, and it's going to be moved around by NEMA 34 12 Newton meter closed loop steppers, just to position the whole thing. At this stage, I'm going to use Linux CNC with all the electronics running through EtherCAT. If that becomes too much for me, I'm going to switch back to Mark IV through EtherCAT, but I want to use Linux CNC because it's a bit cheaper. It's much cheaper, and it allows things like closed loop positioning with the encoders, so that's cool. I believe it doesn't fully support EtherCAT, and I'm finding it hard to find suitable encoder input devices at the moment. I've got a while to go before wiring, so I'm just going to work this out as I go. So while I've been traveling, I've been buying all the bits for this build. I've probably gone overboard already, and I've bought way too many milling tools and tool holders, but at least I won't be short. And I've got a few new tools to help with the build as well, and making one of them workable is the first thing I'm going to tackle. Look at this thing. I've always wanted one of these, just to muck around with nothing else. Only problem is it doesn't do much good here on the floor, so let's get it mounted to the workbench, and the workbench needs some wheels all around it. It's around about 100 kilos, and when I add the arm to it and the vise, look, I just know I'm going to need the wheels so I can move it around better. So those welds are terrible, but I'm glad I've got a MIG now. It's much easier than TIG. So this table is about 90 kilos or 180 pounds for, you imperial folk. And that just moves really, really well. Like, good upgrade. Time for the next bit. Alright, so for the final part of this build, we have this arm here, which is the main pivot point for the tapping arm. So it just slides on there and a little capping thing goes on. I need to work out where to mount it onto this table here. You've seen the vise. The vise mounts over here at the moment, but it can move between these points all over the front of the bench. This is the back side of the bench. So my choices are trying to mount it to straddle the wood and the metal, put it on the wood by itself, or put it on the metal by itself. I could probably use some wood screws for it, but I don't have any on hand, and you know, we're in Australia, so there's a whole lockdown thing going on at the moment, or, well, it is right now. I do have these bolts that came with. So one thing I'm doing is drilling it straight into the steel here, and then tapping the steel. That's 6mm thick steel. That's an M10 by 1.25, so you get 4 threads in it, which is probably strong enough. And then just, you know, putting those bolts straight in there. I think that's a simple solution. I think it's going to work. Only one way to do it now, and that's to, you know, drill some holes. So I'm going to knock off a template, and then we'll get drilling. One goes in, that's a good start. And the rest of the holes seem to line up. Cool. Feels solid. It's not the lightest. That thing is substantial. That is far bigger than I expected. Wow. Looks cool. Alright, so I can't leave you without a demo of how this thing works. First up, you turn it on. Who would have guessed that? Okay, so once you're on the screen here, you select your thread. So I'm going to go for an M10. It gives you the tapping pitch, but you can change that if you want to do something that's not standard. You then put your tapping depth in. That's how far you want to go. You know, the tap I'm using got a little bit of leading on it, so I'm just going to put that to 20 for the sake of this exercise. Tapping speed, we'll get it conservative, about 100. Torque setting, that's got an auto torque timeout on it. Sorry, an auto torque cutoff. I don't need that at the moment. Actual depth, that actually measures how far down it's gone based on the revolution. So you can see there as it spins, you know, each revolution is equal to 1.5 millimeters. And, you know, if you start again, it just starts counting from wherever it is. So it doesn't actually measure the vertical, it just measures how far down it's gone, or how far down it should have gone. And then return speed for how fast you want it to get out. It's a waste of time otherwise. Alright, so what we're going to do is we're just going to tap a bit of a plate here, and we'll see how it goes. Alright, 4 tapped holes. Fantastic. Alright team, thanks for tuning in today. As usual, if you like my videos, you know, just please give me the thumbs up, the like, subscribe, all that kind of stuff. If there's something I've done wrong or something you want to see different, just comment it down below. Otherwise, have a great day and thanks for watching. See ya.